Okay, so if you read the comic, you would see she's looking at all these ramen shops. Now here's a list. It's in no particular order of price. It's just they just label the ramen shops 1 through 50. So a lot of times with statistics, what we start to do is we say, well, let's just organize the data and see if anything shows up that's interesting. So I thought this was kind of a cool way that they represented this in the comic, and they organized the ramen shops by price. So they just pretend, imagine that there's a huge mall filled with ramen shops, and then on the first floor is the lowest price ramen down here, and then the next group all the way up to the most expensive ramen shop up here. And they do it by how much it costs. Now they have to have the low and the high of their price range in here. So any shop that's between those two. So anyway, that's how they organize it. That's the beginning part of what we're doing here. In fact, if you turn it side, it kind of looks like a bar graph, doesn't it? Okay. So you probably have to pile these on top of each other. But anyway, I was just thinking about that. Let's move on. So then they count each shop in each category. So we had 4 shops that were somewhere between 500 and 600 yen, and the midpoint is 550. Now the relative frequency is, there's say 4 out of the entire group. So 4 divided by 50 is going to give you 0.08, or 8% of the ramen shops are in this range. Okay? So that's how you get relative frequency. Let me do it again. So like this one, 600, 700, there were 13 of them. 13 out of 50 gives you 26%. That's relative frequency. So here's our frequency, here's our relative frequency. Okay, let's go to the next thing. So they make 2 different graphs. One where you're going to look at the frequency, right? This is the number of shops that were in between 500 and 600 yen, right there. So it gives us a picture of where we're at. So that gives us a better idea of what's going on. For instance, you could look at it and say, oh, well, the low price and the high price are kind of the same, and we kind of peak right here at this mid-range, right? I wonder why that is. Anyway, something to think about. And then they also do a relative frequency where they look at the percentages, okay? The percent of each ramen shop. And don't forget that when you add these percentages together, it would equal 100%, or if you're doing decimals, it would add up to 1. Okay. So next they talk about bowling scores. So here's the 3 teams. And one of the things that I noticed is that, or you should have seen, there's one really high score and the others are pretty average compared to the other teams. In fact, maybe they're even a little bit lower than the other teams. You have one really good bowler. So what do we do with that? Well, we start by just taking the average. So we just add them up and divide by how, so add all the scores, divide by how many people on the team. That's your average score. It's a way of saying, well, that's about the middle score of this team. The middle score, the middle score. But this doesn't really represent the middle score for this team, because 103 is higher than everybody's score except for this top score. So that doesn't really represent the middle score. So we would use a different type of middle score, and that is the median. And I know you know about the median. You list the numbers from highest to lowest and pick the middle number. When you have an outlier, it's much better to use a median than a mean. You would not use the average if you have an outlier. That's a good thing to remember. Then they talk about how do you find the median. So that's something that you guys learned in, say, 8th grade. And anyway, what you do is you line the scores up from lowest to highest and then pick the middle number. So for instance, for team C, what is the median? Well, there's no middle number because there's an even number of numbers. So you just add these two together and divide by 2, like Ryu did right here. So the median is 82.5. That represents what the middle score would be. Okay, so at the very end, they talk about standard deviation. Now, here's the formula for standard deviation. Let's just say we talk about the bowling team, one of the bowling teams. You take each value, each girl's score, minus the average score, square it. Okay, then you take the second girl, take her score, minus the average, square it. Take the third score, and so on and so forth. Take all those numbers and add them all together. Then divide by how many members of the team there is. So that's what we use when we have all of the members of the team. That would be the population, meaning we have everybody. But lots of times we don't have the population. We take a sample. So, and when we do that, the only difference is that we subtract 1 from the number of values. And the reason for that is if we subtract 1 from the number of values, that gives us a smaller number. Meaning this number divided by a smaller number is going to give us a bigger number by a little bit. So it's just kind of like a cushion to be correct. We just don't want to be wrong. So we're going to take 1 away so we get a bigger standard deviation just to be safe. That's the way I understand it. So let's do a problem. Now I don't know if you know this, but stores like Safeway and Albertsons and Costco are pretty picky about their produce. So when they buy, let's just say, oranges, they all have to be about the same size and about the same weight and about the same color and about the same shape, nice and round, because people like things that are all the same, all uniform. So, and if they're not, they get rejected and they're sold to a store like, say, Save More or a grocery outlet. And there's lots and lots of oranges that are just thrown away because they can't be sold, because people like things that are all the same. Anyway, I'm not going to get into why that is, but let's do the standard deviation. What we're going to do is, I'm not going to make you do the standard deviation for this entire bag. Let's just say we take a sample out of this bag. So what we're going to do is we are going to take, I don't know, just pick randomly 1, 2, 3, this guy over here, 4, 5, and 6. We're just going to pick 6 oranges at random. Now, they want them to be, we're just going to do this variable weight. They want the oranges to be about 10 ounces. Now they can be a little bit, over or under on average, but only by a little bit, about 1.5 ounces on average, higher or lower. So basically, if we get a standard deviation that's more or less than 1.5, then we would reject this bag of oranges, and we might have to test another bag of oranges just to see if they're all jacked up. Now you can have a negative standard deviation because they're all smaller than 10, or all bigger than 10, bigger standard deviation. So anyway, let me give you the values. So as you can see, we have some oranges. This one's perfect, right? This one a little bit bigger, smaller, smaller. Okay, but is the whole group on average smaller or bigger than 1.5 ounces past 10? So anyway, let's not forget what the formula is. So let's see, what do we got? Don't forget, each individual orange, so it'd be like 10 minus the average and square it, and then 12, the next orange, minus the average, square it, so on and so forth for these 6. Then you add them all together. That's what that means. That's summation. And it's 1 less than how many we have in the group. So in this case it would be 5, and then take the square root. So do that, And let's talk on Monday during AST and see who watched the video and who did the problem. Okay, see you later.